Hello IB, welcome to our last topic of the course, the second part of probability. In this topic we're looking at statistical distributions where we get a range of results. We're covering chapters 23 and 24. 23 is all about looking at discrete random variables and 24 is looking at continuous random variables. So in chapter 23, where we're looking at discrete random variables, we're looking at situations where we have looked at already an experiment involving something like counting buttons, red or green buttons, or throwing a dice, things like that. So the variable, so we're looking at these terms discrete, random, and variable. We're putting those three terms together, which might be quite new to you. The variable, in this case, was the colour of the button, whether it was red or not red or green, etc. Instead of words, what we want to do is now come down to see if we can put numbers to things, because once we've got numbers, we can do some maths with it. It's random because we're doing a random experiment. It's nothing controlled about it. So the random variable represents, in this case, the number of possible outcomes which could occur for some experiment, a random experiment. It's a variable since it can take on different values. So any variable like our x's and y's can take on different values. So what we're doing is we're going to say, if we're tossing heads and tails on a coin, whether we have one head or two heads or three heads. So the head, that's going to be our variable. And the number, so let x be the number of heads, and we can substitute in 1, 2, 3, etc., depending on how many times we're tossing the coin. So a discrete random variable x, there's our notation, applies to experiments involving results which are discrete. That means they're whole numbers. And we get that by counting. So we could have different values for x, x1, x2, x3, up to, in this case, how many times we tossed our coin. So we could call different random variables, could be the number of books in your bag. So x is the number of books, and that might have 7 books. X might be the number of shares traded on a day. Anything involving counting, that's what chapter 23 is about. So the probability of a discrete random variable will have a specific value. So we can say, what's the probability of getting 2 heads? It will come out with a specific value. Chapter 24, on the other hand, is about continuous random variables. Random because it's just going to be a random experiment. Variable because it can vary, the value of x can vary. But in this case, it's continuous. Our data is continuous. This applies to experiments where the results can be any value in a range and involves measuring. So the height for Year 12 girls could be somewhere at a guess between 1 and 2.2 metres. I'm just picking some n limits. So it's a range of values and it's somewhere in between there. The lifespan of an ant might be in terms of 0 to however many minutes or hours. However, I'm not sure how long ants live for. But all of these are involved with measurement. So it's not exact. We can't say when is it exactly, 1 minute, the lifespan was exactly 1 minute. It's a value that's read from an instrument and there'll be a limit of accuracy. So if I said if I wanted the heights of students that were 181 centimetres, does that mean 181.000, like where's our limit of accuracy? So all of these, you can't specify an exact point, because remember, a point has no dimension. So it's within some plus or minus value that we're saying we want the height of these girls. So coming back to 23, because we'll look at all that continuous one in the next chapter. So in 23, we're back to thinking discrete, things that we're counting. The probability distribution describes or shows the probability for all the different values of x. So that means we need to know what are all the different possibilities that x could be. So the probability for the particular value of x, we can use this notation. We're saying the probability where x, that's our random variable, equals a particular number. So that's going to be a number in here. So when x is equal to 3, or x is equal to 1, or maybe x is equal to 0. So let's look at our example, tossing 2 coins. So we can display this is discrete data because it has particular values, it's not continuous. So if we toss 2 coins and let x equal the number of heads, remember from your tree diagram, you can go heads or tails for the first toss, and then for the next toss you can go heads, tails, heads, tails. All right. So, back here. So we could have no heads, in which case we have 2 tails. Or we could have 1 head, which means we've got a tail and a head, or a head and a tail. So there are those 2 options. Or we could have 2 heads, which is that option. So what's the probability? How many options are there? 1, 2, 3, 4. So our probability, back to blue, is going to be, in this case, 1 out of 4. It's a quarter of a chance it'll be 2 tails. Here, because there's 2 ways of getting 1 head, it's going to be 2 out of 4, which is equal to a half. And 2 heads is only 1 possibility, so we're back to a quarter. Now note, the sum of these, because we've considered all the possibilities, the sum has to equal 1. So, going back to this notation, if I say what's the probability of x, our random variable, which is the number of heads, equals 0, it equals a quarter. If we want to show that graphically, there's 2 different ways we can see it. One's called a spike graph. So here we've got on our axis the number of heads, discrete values, 0, 1 and 2. The probability is a quarter, a half and a quarter. No, this is not we can't do a line graph for this because it doesn't make sense, because the number of heads can't be 1.5. We could do a column graph. Same story, 0, 1, 2, there are probabilities. Again, this is not a histogram. There's nothing exists. We have no options in here, all right? It can't be in here. It's either 0 heads, 1 head, or 2. So the exercises or practice on this is pretty straightforward. It's just being able to work out what is continuous or what is discrete. So it's all a matter of, are you counting or are you measuring? So counting for discrete, measuring for continuous. So the quantity of fat in a sausage, are you counting something or measuring it? Measuring it because you're going to break it down and then extract the fat and then weigh it. So that'd be continuous. The mark out of 50 for a geography test, are you counting or measuring? You're probably counting up the marks. You're not using a measurement tool. Even if you get half a mark, it's still a discrete value. Your geography test won't come back with an 83.761%. It'll be discrete. Anyway, we'll look at the rest of those in class. The other one here is we've got a supermarket checkout with 4 checkouts, A, B, C, D. The management checks the weighing devices at each counter, and if a weighing device is accurate, a yes is recorded, otherwise a no is recorded. The random variable being considered, and this is always identify that in a question like this, what is the random variable? This is our x, is the number of weighing devices which are accurate. All right, so we be clear, it's that, not that they're not working. You want to say X is the number that are working. Suppose X is the random variables, what values can X have? All right, have a think about that, and then we'll come to class with it. Tabulate the possible outcomes and the resulting values for X. So the first scenario is, we're talking about accuracy. So our first one could be working, our next one could be working, next one working, so they could all be working. Then another scenario is, I'm doing a tick instead of Y's and N's. This could be not working and the other's working. Anyway, go through, if you can, have a go at those questions. Last of all, describe using X the events of two devices being accurate. In other words, what's the probability of X equal to 2? And then here, at least 2 devices being accurate. So think about what notation you can write, and then once you've got this, you'll be able to summarise your results. All right, so we'll have a look at that in class. Thanks for listening, and have a good evening or a day.